Hi, I'm going to show you how to use Google Sheets to analyze linear data. So we're going to use it to make scatter plots. And so I have an example for you. Depending on your teacher in my class, you're going to click on this link. Mrs. Hicks will have a link of some sort to share with you. And so when you open it, it's going to be view only. So you're going to want to make a copy so that you can work with this. So go ahead and make yourself a copy. So we have some data here of some different fast food items and the calories and the fat grams for each item. And so it's just a list. And so basically, what this is going to do is going to show you how to plot these as points. So we're going to see if there's a relationship between the calories in a fast food item and the number of grams of fat in that item. So some things have a lot of calories and less fat. So maybe that will throw it off, but we're going to find out. Okay. So it's really easy. All you do is highlight. So you're going to hold down your mouse and highlight the data. So I have all the data, including the title, and go to insert and down to chart. Okay. And it's going to pick a chart for you. But this is not the chart we want. So I go over here to the right where it says chart editor. We don't want a bar graph. What we want is a scatter plot. And so you can look down through all the different things down here. We want a scatter chart. And so you can see, and it even labels it for you. It has calories here. So as the calories go up, so do the fat grams. So the stuff that makes up McFood has kind of a linear relationship here. So if you can see the better the dots line up into a line, the stronger the relationship. So I'm going to click on one of these dots. And then when I do that, I'm going to go over here because I want to add some things to my chart. First thing I want to do is add a trend line. So it puts the line of best fit, and you can see how close the points are to that line, whether or not it's a strong relationship. If they're really spread out, it's not quite as strong. You can label the data. You can do different things. Down here where it says label, we want to show the equation. So there's our equation in slope-intercept form. And I'm going to show this r squared as well, because the closer that r squared is to 1, the stronger our correlation. This is a really strong correlation. If this number is smaller, it's not as strong of a correlation. And there's other things you can do with your labels, but that should be enough for what we need to look at right now. So there's some questions then that go along with this. So it says use the equation it says find the equation of the regression line, which we already did. 0.0678x minus 6.22. So I'm just going to type that in. So I have it. Right. And then it says use the equation to answer. So on the equation, we just need to know what x is and what y is. So on my graph, x is calories and y is fat grams. So if it says how many fat grams should 500 calories have, I can use my equation to calculate. So I just start with my equation and I can plug in x. So if x is calories, I do 0.0678 times 500. So 0.0678 times 500 minus 6.22, and that gives me 27.68 calories. So I'm going to come back here and type this in. And you can go up to your chart and see 500 calories. You can see where it lines up. Helps you figure that out. Just make sure you're right. So for 700 calories, I'm going to do the same thing. Only this time on my calculator, I'm going to put in 700 instead of 500. Do the same thing, go back to your calculator, type it in, you get 41.24. According to our line, that's what we should get. Now, the other question they could say is, well, what about if you had a McMeal that had 25 grams of fat? How many calories would that be? So the difference here is this time they're telling you fat. So they're telling you the y value. So we're solving in a different way. We're going to set y equal to 25 and we're going to solve for x. So to solve that equation, I need to take 25 plus 6.22 and divide it by 0.0678. And that's 460.47. So roughly 460. We're just going to go with 460. Again, if you go back to your chart, this time if you went to 25 grams, which is right in here, and go down, you should be at about 460. How many calories would a McMeal with 30 grams of fat this time have? So to set it up, 30 equals 0.0678 x minus 6.22. Same thing, we're just, this time we're going to add 6.22 to 30 and divide it by 0.0678. You get 534. So to talk about strength of correlation, again, we're going to look at this number up here, and you can see it with the line, how strong it is. But if you take the square root of that number, that will get you the correlation. So in this case, the square root is 0.983. That's almost equal to 1. That's a really strong correlation. And that's probably because the fast food, the type of things that go into fast food, they're high fat, and so the more calories, the more fat. That would not be true with everything that you eat. If you ate a whole bunch of fruit, like if you ate 10 apples, you would have high calories, but your fat might not fit that pattern. Okay, so again, let's go back and review the steps. All you do is highlight all of your data and go to Insert Chart. Okay, so if the data is not there, you have to type it in yourself. But if the data is there, which you're going to have on these examples, you literally just go and type it in, or you go and highlight it again. Okay, so you make sure you go down, include the labels, and then once you get your chart, you can do whatever you want. So on this paper, on this document, we're going to have two other problems to work through. There's one of them that is drugs, concentration, and the score on a math test. I got this data off of a data site, so I don't know what drug they were testing for, but these were the average math scores, and then the percentage of that drug that was in their system. So you're going to find that and use it to predict and answer some of those questions. The other thing that you might think about is the correlation positive or negative? This was a positive correlation. It was getting bigger from left to right. With drugs and math, as your math score goes up, if you can see right here, as the math score is a 7, the drug concentration is lower. So that probably will be a negative correlation. And then the last one you're going to work on is this is from a few years back, but it's accurate data on the price of a hybrid vehicle. So that's this MSRP, that's the manufacturer suggested retail price. and the miles per gallon that the hybrid gets. So the question is, if you spend more on your hybrid, does it get more miles per gallon? And so when you highlight here, you're not going to want to highlight the names. That's just for you guys to know, to see it. Again, some of these are old, like maybe 10 years ago. So this is hybrid, kind of early hybrid, but this will give us a relationship to see if we spend more money, are we going to get better gas mileage, and then how strong that is. Okay, so go ahead and go to the drugs and mass score and make your graph and get your equation, start answering the question. We'll go over that in class. And then same with the hybrid vehicles.